Behave. Okay, ready? Day 4. I can solve quadratic equations. I can solve quadratic equations. Last method is completing the square. Completing the square. This is the one most people tend to forget. Okay? Good thing our exam isn't too far off, because I don't know why. Remember the factoring, we remember quadratic formula, but for some reason complete the square. Like a month later, we're like, oh, I don't remember that at all. Don't be that person. Okay? For some reason, we seem to forget this. But for those people who like steps, it's very systematic. Step 1, divide everything by your A term. Everything. On both sides of the equation. Step 2, move your constants to the other side. By that I mean this is not a case where we equal 0. Factoring in quadratic formula, we had to equal 0. In this case, we do not. We take that constant to be on the other side. So I have all my variables on one side, constants on another. Then here's the weird part. We're going to add the quantity of b over 2 squared to both sides. It's our magic number. It's our magic number there. Because when you do that, you should now be able to factor. And when you factor, it will become a perfect square. Perfect square. Which makes it easy to then solve. Okay, so all these steps are the same. 1, 2, 3. You do it all. Every single problem the exact same way. So let's start. In this case, my A is 1. So I don't need to divide everything by 1 because I get the same thing. I don't need to do that step. I do need to take the constant over. So this constant term needs to be on the other side. So I get x squared minus 9x equals negative 12. Okay, step 3 says I'm going to add b over 2 squared. We can go off to the side and find b over 2 squared. B in our case is negative 9. Yes? Now you can write it like this. That will actually be 81/4. Correct? Yes, no? I'm going to keep both versions here because we're going to use both. That's what I'm going to do. Is we're going to add that to both sides. So I get x squared minus 9x plus 81/4 equals negative 12. Oops. I don't know why I drew a line there. Plus 81/4. You add it to both sides. Because here's where the magic happens. Here's where the magic happens. This side, when you add that b over 2 quantity squared, this will factor perfectly. Okay. Now, this one, would you think by looking at it that it factors? Fraction, what two numbers multiply to be 81/4 and add to be negative 9? Ugh. Is that not gross? Fractions? It does factor. It does factor. And here's how it factors. We're going to skip the ABC method process because it works out every single time. What it's going to factor to be? It's going to factor to be x. Anyone know? It's going to be plus your b over 2 squared. Every single time it's going to factor that way. So in our case, it will factor to be x plus, what was our just b over 2? Notice it's not b over 2 squared. That was negative 9 over 2. See in here? That's why I kind of write it like that before I square it. That's what's always going to factor to b. Now help me out. What do we get on the other side? You guys all have your calculators. Grab them. Get the calculators out.
or 33/4.
Give me fractions.
33/4.
what'd you get, 33/4, so you said?
Yes.
Anyone else get that? Okay, let me show you as my calculator comes up. If you have an Inspire, which once again, next year if you're taking pre-calc, you're gonna use them. Oops. I can go to Menu, Algebra, Factor. And let me show you the left-hand side. We had x squared minus 9x plus 81/4. I can't remember if I have to do a comma x or not. Oh, it's just going to go ahead and do the perfect square anyway. Ignore that. I was hoping it would show it perfectly, but it doesn't. It gets a little fancier. But anyway, we'll do one that has a whole number, and I'll show you why it works out. Now from here, we can solve algebraically. There's no b term there. Okay, so let's just solve this. To solve it, how do you want to do a square? Careful. Careful. Plus or minus. So the square and the square root undo each other. I get x minus 9/2 equals plus or minus square root of 33/4. Now we have to get fancy. Take the square root of the top and the square root of the bottom. That will give me plus or minus square root of 33/2. Anyone see where I got that? I took the square root of the top, square root of the bottom. Bottom's perfect square. Now does 33 treat? No, we get 3 and 11. We don't get any pairs. Okay, but you have to check, see if it treats. Now last step is to add 9/2. I like to put it in front. There's really no reason. Just because I like to lead with the number and then have the square root. It's just me personally, but there we go. And that's about as messy as they come. That's one of the messier ones. So if you follow that, that's one of the messier ones because we have all those fractions. Let's try another. This one's a good one to show you that factor's perfect. Okay, so first step, divide by a. A in this case is 1. I don't need to do that. So let's take that constant over for step 2. Now I need to add b/2 squared. Well, in our case, b is 8, which is really 4 squared, correct? Reduce that fraction if you can. 8/2 is 4. Use those old numbers when you can. Last one we couldn't. It was 9/2. Okay. So now what's going to happen? Add that to both sides. X squared plus 8x plus 16. I add it to both sides. Okay. Now check this out. I'm going to show you the magic happens. What I call the magic happens. Remember, it will automatically factor to a or x plus whatever was in the parentheses, your b/2 will always be b/2. In this case, that would be 4. Now, this is a good one for me to prove to you that that magic step happens because it's whole numbers. If I were to ABC method this, I need two numbers that multiply to be 16, add to be 8, well, 4 and 4. Then x squared plus 4x plus 4x plus 16. Pull out an x. Pull out a 4. I get x plus 4. X plus 4, which is x plus 4 squared. Bam. Every single time that works that way. Every single time. It will always be x plus b over 2. Always. Always, always, always in there. You don't need to show this. I just want to show you that I didn't make this up. This number is special, that b over 2 squared. That's what makes it a perfect square, which is why we call it completing the square. It's not a perfect square yet, but we add that special number so that it is a perfect square. We're completing the perfect square. Okay, that's why that's called this method. Now let's solve plus or minus square root. Square and square root reduce. They undo each other. So I have x plus 4 equals plus or minus 6. I can go ahead and take the square root there. Okay, so now think about it. I have x plus 4 equals 6, and x plus 4 equals negative 6. So here I get 2, here I get negative 10. Any questions? The key thing is this step from this step. It will automatically factor to x plus b over 2. X plus b over 2. Always. Quantity squared. Questions so far? Let's try another. Okay. What do I need to do? First,
Divide by
divide by a. So everything. Even the other side, divide by 2, divide by 2, divide by 2. Even that other side, you would divide by 2. So here I get x squared minus 4x minus 7 equals 0. But don't forget to divide the other side. Now in this case it was 0, so it doesn't matter. But if that's another number, it definitely matters. Okay. Now take that constant over. So in our case, we want b over 2 squared. So we're going to add to both sides. So in our case, negative 4 over 2 squared, which is negative 2 squared. Going to add 4 to both sides. Okay, here's where the magic happens. This is always going to factor to be x plus b over 2. What was b over 2? Negative 2. If you have to do it over again, do it over again. b over 2. Yeah.
Let's look at the problem, like the initial problem wasn't set to 0. Before we divide by our a, would we subtract over, like let's say we do.
It actually doesn't matter. If you take the constant over first or you divide by a, those two you can switch.
Okay.
Doesn't matter. Does everyone follow? This is the step I'm worried about right here. X plus b over 2. And when I say b over 2, it's from here, not your original. You had to already divide by a. Your b over 2 here. This case equals 11. Plus or minus square root both sides. So I get x minus 2 equals plus or minus square root of 11. Add 2. I don't know why I like to put it in front. Just so it's kind of in that standard form. And does 11 tree? No. So we're done. Here we go. Starting to sink in. We're just going to do several of them because once you do a bunch, it's just the same process over and over again. But we have to watch our arithmetic. It's that reducing the square roots that gets us usually. Okay, first step. Everything by 3. So I will get x squared plus 2x plus 2/3 equals 0. Let's take that constant over. Okay, let's find b over 2 squared. So in our case, b over 2 squared is 2 over 2 squared, which is 1 squared, which is 1. So let's add 1 to both sides. Now, here's where the magic happens. In this one, you could actually, you got stuck, you could ABC method that. These are nice, neat whole numbers. You end up with x plus, what was your b over 2? You're stuck. Look at your b over 2, it's just 1. That side I get 1/3. Now let's solve algebraically. Plus or minus, square root both sides. Okay, here's where it might get a little messy. I'm going to go ahead and take the square root of the top, square root of the bottom. So that can be plus or minus square root of 1 over square root of 3. You with me so far? I'm going to go off to the side here. That is plus or minus 1 over square root of 3. 1 is a perfect square, so I took the square root. But I better rationalize, right? The times square root of 3 over square root of 3. Be plus or minus square root of 3 over 3. Here we go. So I had to reduce. In this case, I took the square root, but I have to rationalize. Gotta get that out of the bottom. So all of these rules with our square roots still apply. Last but not least, subtract 1. I like to write it in front. Don't know why. Just do. Here we go. Beautiful. Questions? You guys are awfully quiet. That means we're understanding, right? We'll find out, I guess, tonight in the homework. What do I do first? Divide by 2. Generic divide by 2. Lazy man's way. X squared minus 7/2 x plus 6. Take that 6 over. Ooh, this is a good one. This one gets a little messy. Alright, so let's go find our b over 2 squared. Well, b in our case is negative 7/2 over 2. Now, you do have a calculator. This one's not bad. That's actually negative 7/4 squared, which is 49/16. You do have calculators, though, if they do get terribly messy. You need to do negative 7/2 divided by 2 in this case. So I'm going to add 49/16 both sides. Okay, magic happens. X plus, well, what was b over 2? Here's b. You would put that over 2. That's actually negative 7/4. Remember, it's not b over 2 squared. It's b over 2. Okay, inside the parentheses is b over 2. So I take my b over 2. And that equals, help me out. What do we get over there? Grab your calculators. Help me out. 49/16 plus negative 6. Give me a fraction. Is that correct?
Yeah.
47/16. Negative? Oh, I see where this is going. Now, plus or minus square root. Square and square root undo each other. Hold up. There's a negative in the square root. All that work for no solution. I know. Questions? Two more. Divide by 3. Everything by 3. Both sides. That's x squared minus 4/3 x plus 5/3. 0 divided by 3 is still 0, but make sure you divide that other side. It's common error, I see. Take over the constant. find our b over 2 squared. So in our case, that would be negative 4/3 over 2 squared, which is actually negative 2/3. Or check me on that. Pretty sure it's negative 2/3. Check me.
Yes.
Yes. Didn't sound too convincing.
Yes.
Okay, thank you. Square root, I get 4/9. So let's add 4/9 to both sides. Oops, and I didn't write it on this side. What was I doing? Okay. Magic happens. Here's our magic happen step. X plus b over 2. If you're stuck, you can do it again. Do that divided by 2, but we did it over here. That's b over 2. What do we get on the other side? 7/9? Oh, that one needs times 3. Negative 11 ninths? Is that what you said?
Yeah.
Ho, ho, ho. You see what's going on? Minus. What's going on? No solution. You've got a negative inside your square roots.
Why can't we take out our 9?
We will. We're getting there. We're working our way up. We will. It's actually the next section.
I still don't understand like how we get negative 2/3 in
Here.
yeah in there.
We took, when you factor, it's always x plus b over 2. So what I did is I found b over 2. So b is negative 4/3 divided by 2. You can use a calculator, but that's going to give you negative 2/3. So that's what goes here. Questions? I think we have one more to you try. Bear with me. Divide by 2. I hope this one's not another no solution. And take over that constant. If so, I'm going to change it for next period. Oh, it's too many no solutions. It might be. I think it's going to. Okay. B over 2 squared is 11 halves over 2, which is 11/4 squared, 1/21/16. And you do have a calculator. I'm just a math whiz, so I'm awesome at it. I get, add that to both sides, x squared plus 11 halves x plus 1/21/16. Oh, this is going to be a no solution, I can tell. 15 halves plus 1/21/16. Wait a minute. Yeah, it's going to be no solution. What do we get on the other side?
Dang it.
I'm going to change this for next period. Ooh, 1/16? Positive 1/16?
What? No, not in there. Sorry.
Not in there,
On the
okay.
other side of
That's what I'm talking about. In there?
Yeah.
Ooh, okay, good. I was hoping, I thought it was going to be another no solution. But anyway, so we get 1/16 there. Anyone else get that? Yes, no? You have calculators? Do it.
I got negative 1,815 over 32.
Well, you got it wrong.
That's not, yeah.
Oh, I multiplied them.
Yeah, I was ahead. 1/16?
116. Yes.
There we go, 1/16. Okay. So here, this is plus b over 2. So that's 11 halves over 2. There's your b over 2, which is 11/4. Whew, I thought it was going to be another no solution. Yes. Plus or minus. So I would get x plus 11/4 equals. Now, These are both perfect squares. Remember, you can take the square root of the top and the square of the bottom. Now, you might have to tree those or rationalize, but in this problem they both work out. What do you get? 1/4. So I get x plus 11/4 equals 1/4. X plus 11/4 equals negative 1/4. You have to do both cases, plus and minus. Okay, so let's solve it. Minus 11/4, negative 5/2. Yes, no? Yeah. And then minus negative 3. There we go. Some of them will end up being square roots, some of them will be perfect rational numbers. How about you try? That's when you square it, but when we're in the parentheses, we want b over 2, not square it.
Oh, okay.
So in the parentheses,
That's just B.
it's just b over 2.
Okay.
Mhm. Gotta make do without the solids, right? Square root. They're a pain, I know. Get your calculator again.
Possibly.
Mm-hmm. What?
Oh, I got it wrong. And I
Stop.
couldn't figure out why. I couldn't figure it out.
Okay.
You would know you lost brains.
Yeah.
Another
No.
bit to finish up.
No. Don't. Don't even start.
Okay, get your cards.
Can you not?
Okay, let's go over it. Okay, so first divide everything by 4. take your constant over. Now, what you're adding to both sides is b over 2 squared. But what goes inside is just b over 2. Okay? So you add b over 2 squared right here,
No.
but in the parentheses it's just b over 2. Okay? So then, take the plus or minus square root, take the square root of the top, and the square root of the bottom. Now the bottom just ends up being 2. Nice and neat. It's not under the square root anymore. Okay? Make sure I don't see something like this. Sometimes it's iffy to know if it's all over 2 or if it's this. Because I see them both. So be careful with how you write. So my messy writers need to be very clear as to what they intend. Okay? So then final step, add 1 to both sides. Questions? Homework. Day 4. I don't know why it cuts off every day until I touch it. Okay, so day 4 homework. You get to color Christmas. Christmas coloring. So you have 8 or 10 problems, I think I have. 10 problems. Okay, find the answers. Tells you what to color. And you've got your Christmas tree. Color your nice, pretty Christmas trees. See the background. And all the little ornaments, these little ones, those are 10, number 10. Just all right in there. So you've got your pretty Christmas tree to color. Okay? Questions?
You have a Hanukkah or something?
I don't, I'm sorry, no. But still color a pretty
Looks like
picture.
Can't do it. Can't do it.
Okay. Alright then. You've got a few minutes to work. You've got at least 5 minutes or so.